We're here at Moffett Airfield at the largest wind tunnel in the world. Joining me is Malcolm Thompson. He's a new executive director of FHE Manufacturing Innovation Institute. Congratulations, Malcolm.
Well, thank you very much. We are delighted and privileged to get the award. It's a very exciting and momentous day for us.
Well, moments ago, Secretary of Defense Ashton Carter had announced that the FlexTech Alliance has won the federal funding award for flexible hybrid electronics. Can you tell us what this means to the FlexTech Alliance and all the companies that are your member companies?
Yes, it's a great award. We've been working in flexible hybrid electronics for some time now, and essentially making prototypes and showing what could be done. You see around this exhibit all of these. But our mission now is, as a manufacturing institute, is to basically mature the manufacturing processes so that we can make and manufacture these devices like wearables, like sensors that fit on planes. There's a whole wide range of applications there. And we have a network of over 100 companies, over 40 universities, and we are going to work together to develop that infrastructure and have a very mature manufacturing processes for all of these devices.
Now, Secretary Carter, of course, was stressing a little bit how the results of all of the flexible hybrid electronics are going to be benefiting our military and providing the leading edge technology for them. Now, we also know that that technology can transfer into the commercial side of things. What are your thoughts on that?
Yeah, I think it's very, very interesting. You know, the notion here is flexible electronics. So imagine putting a flexible electronics over an entire aircraft wing and measuring the stresses in the wing. If we all get on a plane and we're up in the air, you know those wings flap. That's one of the applications. You can use that same device to go on a bridge, a building. You can do various things. For the military, you can also put antenna on their wings to make communications very much easier. We have other applications where we actually wrap flexible electronics around an engine, and essentially it listens to the engine continuously, and if suddenly things start going wrong, you see a noise coming from there, and so you could do preventive maintenance. You could intervene. And so automobiles, aircraft, these are some of the sort of applications that you can have for mechanical measurements. Then there's also, of course, the medical applications, patches, electronic patches. Patches that you put on a soldier or a pilot where you want to measure, you want to find out how stressed they are, how fatigued they are, and even how clearly they're thinking, measuring the cognitive capability of the pilot. That's very important, and we've developed these devices that you can see around here for that.
I know you had a wonderful story that you had shared earlier about one of the sensors having an application in a whole different industry. Can you share that with us?
Yeah, it's really interesting how this transfers. One of the applications is to measure the chemistry in the body through sweat. You know, we all have a blood test done, but you can't measure the chemistry continuously. It's one test and you go away and you get it analyzed. So we are developing a sweat patch which measures what are called biomarkers and chemicals in the body, and you can predict these stresses, fatigue, and all these cognitive capabilities. So I got a call from a pediatrician who said, "I'm really interested in your sweat patch." And I said, "Well, do you mind telling me why you're interested in a sweat patch?" She said, "Yeah." She said, "It's very simple. I deal with highly premature babies, and we can extract no or very little blood from the baby. And this is a very anxious time because we need to know if that baby's stressed, and we need to basically give it some medication. So if I had a sweat patch and I stuck it on the back of the baby and continually monitored how stressed they were, it's just a revolution in my business to be able to do that. So this really changes the way we will work and change the dynamics of caring for premature babies. So I thought that was a neat story.
Well, it is a wonderful story, and it is giving us a good sense of the revolution underway, you know, especially with the Internet of Things, as everyone has been talking about. Put a sensor on something, everything becomes connected, you can monitor and analyze from there on out. So, Malcolm, I'm going to let you go right now. There are many other people looking to talk with you. I do want to say congratulations. But before I let you go, what are your next steps now as a new executive director?
Well, my next steps is to sign up all these companies formally. So we need to have a participation agreement, which we are really getting almost completed. After that, we look at our annual plan. What projects are we going to work on? And we do that by getting all the industry and universities and decide on where the gaps are in the roadmaps, what we call roadmaps to develop the technology. And once we decide that, we release an RFP, which is a request for proposals. We get these back. We essentially then start the projects. We start the Manufacturing Institute, which is a capability for producing small-scale manufacturing here in San Jose. So those are the next steps. I think it's going to be a busy time.
No doubt, but you're the right man for the job. So congratulations, Malcolm, and we appreciate your time, and congratulations again.
Thank you.
In Moffett Field, I'm Angie Kellen.